Well, hello everybody at home. It's a happy Monday or a rainy Monday for us. You'll be getting this on Tuesday. And today, as we continue our work in Bridges, we are going to do some reviews since for us it is Monday, and so we have to remember what we did last week. We're also going to be playing one of the games that we learned last week called A Race to 100. So as we begin, we're going to talk about what we've learned, and I just realized I don't have our doc cam ready to go, so please be patient. And this is what we're studying once again. Last week, we introduced our I can statement as I can use the distributive property when playing the workplace game called A Race to 100. And we definitely use the distributive property, which is something I'm going to review again. But before we get to our game, everybody's going to need to find their workbook, our Bridges workbook. And we're going to be starting on page 20. We're not going to do the challenge problem. But on tables, the students are going to make one array to follow along with the class quilt according to what our directions tell us. So it says Mr. Carpenter's 28 students are making a paper quilt. Each student decorated a square piece of paper. Now, Mr. Carpenter has to decide how to arrange the 28 squares. Help him find the best way to arrange the 28 quilt squares. So what we're going to look for, how many different ways can Mr. Carpenter arrange the 28 squares? In other words, how many arrays can he make? And then you're going to draw the arrangements and label them with their factors. We're going to do the dimensions. So this is our workplace. For those of you at home, if you need to use things like pennies or dimes or marshmallows or chocolate chips or something like that, so you have 28 of the same type of thing, you can use that and you're going to lay them all out. We're going to pause as we work through this, and then we're going to come back and talk about it. So we'll talk to you in a little while. I got to get back to our other screen. Hello, everyone. We are back. We've taken a little time to do some work. We're back to our workbook, and I'm going to do a hint right now before we actually discuss. Remember, if we're looking for the different ways, and we're supposed to be finding the factors. Did anybody think of this to know if you found them all? So what would be the first number we would start with for factors? Reese? 1. And if 1 is on this side, what's on the other side? 1 times what, Brooklyn? 28. What comes after the number 1? Phoenix? 2. If 2 is on this side and this one doubled, that means this one's cut in half. And what goes the opposite of 2? 2 times what? Addison, are you being brave? Oh, okay. Adrian? 14. How many of you tried 3? Did it work? Okay, Tucker's shaking his head no. 3 didn't work. Does 4 work? Okay, so 4 times what? Brooklyn? 7. 4 times 7. Did anybody try 5? Okay, we have a table that tried 5. It didn't work. Did anybody try 6? Okay, we have another table that tried 6, and that did not work. So here's our 3 combinations. 1 times 28 is the same as 28 times 1. 2 times 14 is the same as 14 times 2. 4 times 7 is the same as 7 times 4. Or in other words, remember when we made these? We have 3 different ways, 3 different arrays, 3 different ways to do the quilt. And remember, some of you were thinking, oh, well, 4 times 7 and 7 times 4, or 2 times 14 and 14 times 2. When I turned this poster, have I changed the arrays? I turned the poster. Did I do anything about changing the arrays? No. I have not even touched them. I'm only touching the orange. So the white squares remain the same. It's just looking at them in a different way. Remember, does anybody remember what that's called? Starts with a C. Phoenix. The commutative property. Remember, you can put them either direction, but you're going to get there. So if you switch them around, you can still get there. Okay, now let's answer the next question, because everybody should have these types of things written on their paper. Number 2, which arrangement do you think Mr. Carter should choose for making the quilt, and why? Okay, Luke, what do you think?
I think they should do 4 by 7 because it's the most like a quilt.
Okay, Luke says if 4 times 7 is the most like a quilt. And nobody's challenging that. This is kind of a skinny quilt. This is a really skinny quilt. I don't know how you'd stay warm with that. Okay, now what? Look at this. A new student joins Mr. Carpenter's class, and now he has 29 quilt squares to arrange. How many arrays can he make with 29 squares? Of course, we're going to pause while we figure this out. You at home, you're going to need to get one more item to try making arrays. Okay, we are back, and students have been working really, really hard in the classroom. There were numerous strategies going on, and I know some people were thinking of this right away. They thought of their 29, and almost every single person in here knew that it was 1 times 29 is our first set of factors. And then we had one table that was trying to rearrange, where they started with 2. And they discovered that 29 cannot be divided in 2. 29 is an odd number. Can 29 be divided in half? No. It cannot. So then the next number they tried was 3. They had 2 extras. That didn't work. Well, now I want you to think about this. If we're thinking about, well, if 2 didn't work and 3 didn't work, if we get to 4, is 4 going to work? No, 4 can't work if 2 doesn't work. Think about it. If 2 didn't go into it, how can 4 go into it? Eventually, you'll get into factorization, and you'll understand the reasoning when you get a little older. Okay, now some people tried 5, and they just counted on their fingers, and they knew that didn't work. So will 6 work? Definitely not, because if 2 didn't work, 6 won't work. So in other words, any even number is not going to work. So then we get to 7, and we just did 7 times 4, and so we know it can't work for 29. Then we're to 9, and some of you have already made the 3 by, I have discovered that 3 times 7, or 3 times 9 is 27, and you end up with 2 extra. So we know that this is the only one. And it looks like this. This is all there is. Now, Millie was using a different strategy, and she's going to come over and show what she was doing. And apparently Luke does that on their table too. And I don't know how many other people use this, but it does work.
So I looked on my ratio table, and I looked around for a 29, and I couldn't find any, so I knew that there's only a 1 times 29.
Okay, that works really well. Because your multiplication chart is like a whole bunch of little ratio tables there, or a whole bunch of little factor charts. So you discover it doesn't work. All right, you can use that to discover it doesn't work. Or one table already knows that these posters are up on the board, and so they were looking at the posters and they knew. So these posters are up in the class. Okay, and as I said, we are not going to do the challenge today, but we discovered that there was only one way to make this. Now we're moving on to Page 22. Page 22. Again, we're doing some work. Those of you at home, you'll do a little work like we do and pause while you're working, and then come back and see how you did. And please listen to students' explanations. You might learn from your classmates. Every year I learn something new from students. So it says, Claudia loves to collect shells at the beach. She has a large collection of shells, and today Claudia is organizing her shells. Write and solve an equation for the problem below. You need to write an equation. You're solving for an equation. I'm going to pause while we work, and we'll talk to you in just a little while. Okay, we are back, and we've been working really, really, really hard, and some of us are having brains that hurt. Anyway, when we were working this through, some of the students chose to make 4 groups with 6 in each of the groups. Or if you think about it, we have 4 groups. There's our 4 groups. We have 6 in each one. 4 times 6, 4 groups of 6. What is 4 times 6, everyone? Anna? 24. So we have 24 small shells. How many of you actually wrote down what 24 meant? We tend to skip that part. Moving on, now Claudia made 8 groups with 6 medium shells in each group. Did anybody notice that our 4 doubled to an 8? So if our 4 doubled to an 8, what can we do with our product? If our 4 doubled to an 8, one of our factors, then we know something happens with our product. One factor stayed the same, one factor doubled. So what is 8 times 6? Luke? 48. Again, look at this. There's the 4, there's the 8, it doubled. There's the 24, there's the 48. 24 plus 24 is 48, it doubled. Looking at this next one, we have 9 groups of 6. Did you notice the difference between the 8 and the 9? It means we have to have another group. Or we have to add one more group. And how many are in each group? Think about this. We have 6 shells in each group. So we have another set of shells added. Or how many of you know your multiplication tables? Okay, the table right in front of me, all have their hands in the air. What is 9 times 6, everybody? 54. So we have 54 large shells. Remember, I told you, you can use your multiplication chart. Your multiplication chart is 2 pages in front of you. I told you to mark that with a sticky note. Okay, we're not taking the time to do the challenge just because of time. I'm going to call people's sticks and people can come in and do our number line puzzle. You can say thank you or no thank you as I call you. Trevor. Kiona. Tucker. You have to fill this in, sir. Right here, you have to fill this answer in. Phoenix. Millie. Luke. Will. Safira. Carter. Carter, Carter, can you do 4 times 7? You work on that, and then we'll get somebody else over here too. So are you ready? 4 times 7, Carter. And Adrian, do you know 8 times 7? That's one of those really, really hard ones. Marshall, do you know 8 times 7? That's, again, that hard one. Akaya?
Main list number.
Is it 56?
Yes. 28.
Okay, thank you, Carter. Carter told us it's 28. Okay, so here are the answers. Please check your answers. Again, side note here. Many of you got 6 times 7 correct on your multiplication test. What is 6 times 7? 42. So what do you think we should move on to next? This really nasty one right here?
Yes.
Yes, okay, so that's our nasty one we're gonna work on next, which is 8 times 7. So what's 8 times 7?
56.
What's 7 times 8?
56.
What's 56 divided by 8?
7.
What's 56 divided by 7?
8.
What is 8 times 7?
56.
What's 6 times 7?
42.
42, okay. Woo-hoo. Okay, everybody now at home, you are going to need your math journal. The class is going to get their math journals out as well. And we'll hear a bunch of noises. Everybody's getting ready. Keep them for now. Please put them to the side. Okay, remember how I taught you to put the title at the top? This is a problem string. And today is September 28th, 2020. Remember that I will tell you how to set this up. And it's a really good idea to follow along as I set things up so that you have enough room to work. So I'm going to write the word problem in the margin. Because remember, we have to go all the way over to the edge past this little red line. And this is the margin, gives us extra space. I'm thinking that once I write the word problem, that's all the bigger or all the more room I'm going to need. So I'm going to draw a line going down. Some of you always ask how I can draw a straight line. All I do is I just pull my arm towards me, and that helps me make a straight line. And then this is the strategy. We are talking about some strategies. And we are starting to make our turn towards doing area model or tile arrays more than what we're doing anything else. I went down 2 lines just so that I have room. As you know, I always use different colors so it stands out better for you. So I've made a T-chart. Our problems that we're working on are going to be on this side. Our strategies are going to be on that side. Okay, give me a thumbs up if you're ready out there. Okay, got a couple people still finishing up. Okay, our problem we're going to work on. This would be called an expression. I have 3 times 4. This is called an expression right now because it does not have an equal sign. If I put an equal sign on it, now it becomes an equation. If you can hear that equal and equations kind of sound the same when they start. So we're going to start out, first of all, talking about how we can use tiles, or we can draw the tiles to make an array to help us figure things out. So I'm going to start out. I want to give myself a space of 2 above here. So I'm going to think of this 3 times 4. I'm going to go 3 lines down, but I'm going to make lines that aren't connected. So there's my 3. And I'm going to go above this and make 4 lines going across. 1, 2, 3, 4. My factors are 3 and 4. And now I'm going to fill this in as an array. I'm going to draw the edge, draw another edge, making it into a rectangle. Remember, the arrays we're working with are rectangles or squares. We try to make it as even as we can, but because we're trying to be fast, it may not be exact. And over here, I'm going to draw another one of those without the lines on the inside. I drew lines across because my factor tells me I need to have 3 rows. I drew lines down because my factor says I have to have 4 columns. So I have 3 rows. I have 4 columns. I'm going to put my factor there. 3 and 4. So this is my tile array. This is an area model. This is our tile array. This is area model. And our expression over here says that we are doing 3 times 4. I've changed it into an equation now. And 3 times 4 is what? 12. That's all the longer this part is. We're going to move on to our next expression. Okay, so that I have enough space to work, I'm going to make certain I count down 3 lines. 1, 2, 3. See how I counted down the 3 lines so I have enough workspace above. What I can do if I need to work with 3 times 8, just like in our workbook, I was talking about how we had the number, oh, now I forgot. Oh my goodness, short memory here. I'm going to look it up so I'd say my numbers correctly. Okay, when we were working in here, we went from 4 groups to 8 groups. We had a double happen. And then we noticed something happened with our products. We're going to talk about that here. What I'm going to try to do is make this array or this area model here about the same proportion as what I have on top. So I'm going to draw this as about, let's see, there's about there and about there. Did you see how I kind of made a little stopping point right there? So think about it. So draw about the same amount here as you do there. I'm going to go down 3 lines. I'm going to stop and wait. I'm going to draw this really long line. but I'm going to make this line in the middle. Remember, I said I was going to cut that in half. Because I already know something. I already know that 3 times 4 equals 12. I also know that 4 plus 4 equals what? Yes, 8. So how do I know what the factor is on this side? Who thinks they're brave enough to explain? How do I know what the factor is over here? Millie.
Well, on the other side is 3, and that's an array. It's parallel.
Okay. Oh, she's using such great math words. Okay. So she says she knows that this side is 3. She knows it's an array so that the sides are parallel. That's a really good math word to use, parallel. So we know it's 3 on this side too, just like the top and the bottom are going to be parallel. So on this side, we also have a 3 times 4 equals 12. So we know that 12 plus 12 equals 24. So now we're going to get down on the bottom here. I'm going to draw some arrows so we know where those numbers come. And this is what you actually just did. You thought of this. You saw 3 times 8, which also can mean 3. You see this one? Times. Now here's a thought that we're having. We used to have 8, but we broke it into this number and this number. Because we can only think of 2 numbers at one time and we broke it into 2 numbers, we have 4 times 2 because I have 2 4s. So 3 times 8 is the same as 3 times 8, right? Some people just put their head down and they just thought this was downright silly. It will continue to make more and more sense to you. And as you get older and older, you will start doing things like this in math, but the numbers are more difficult. So, okay, so in our heads, we are doing something called the distributive property. We distributed the 8. When I did this, I distributed the 8. See, look, here's my 8. See my 8 up here? It's distributed. You do not have to do this. This is for your benefit only. There's my 8. I distributed 4 over here and 4 over there. Oh, sorry. I distributed my 8. I put 4 over here. I put 4 over there. 4 plus 4 is still 8, correct? When we were playing our game last Friday, we were distributing some of our factors when they didn't fit in a nice little array. So this is showing the distributive property. I hope that you wrote the word distributive. That's a tough word. Do as best as you can with distributive property. This is what we did. We distributed the 8. We changed it to 4 plus 4. Four plus 4 can be thought of as 4 times 2. That is what your brain was doing. When we get back from gym class, In class here, we are going to play our game Arrays to 100. At home, you are going to play Arrays to 100, but we're not going to be live for that. So as everybody's finishing up here, I'm going to just review a few words that we've been learning. When we were working with, now the students are going to yell when I do this to them. When we were working with the numbers 28 and 29, we know that this is composite because it has more than one array. And this is prime because it only has one array. Those are some of the words we used. We've been talking about factor pairs. 3 and 8 are a factor pair. Our product is 24. We talked about the commutative property, and now we've just learned about the distributive property. Equations have equal signs in them. Expressions do not. And dimensions are like talking about the factors when we do an array. So tomorrow we will probably review what it means to divide or to distribute our numbers, our factors, when we're doing more difficult problems. And tomorrow we'll be learning another game. So with that, everybody here is going to tell you bye because we're going to gym class. So bye.
Bye.